Okay, so in this lesson I'm going to be discussing rational exponents and basically how these rules are derived. So we're going to start off with this equation, which is one of the basic rules for combining rational numbers with similar bases or the same bases, and then I'm going to show how this equation can lead to this one and a more generalized form of this one. Okay, so let's get started. The first thing is that we're going to start with this x to the a times x to the b is equal to x to the a plus b. So x to the a times x to the b is equal to x to the a plus b. Right, and what we're going to do though is we're going to speculate that if I wanted to find the square roots, okay, so what I want to do is I want to find what are the square roots of a number. Okay, so what I'm going to do is I'm going to do an example in parallel here. So I'm going to say I'm going to have 2 to the something, 2 to the x, or well, I'll just say a, okay, times 2 to the b, and that's going to be equal to 2 to the 1, okay, or just 2. Okay, and what I know though is that 2 to the a must be equal to 2 to the b because I want them to be both the same thing. Okay, and that way if a is equal to b, then basically you have 2 of the same thing multiplying to get 2, which means that it has to be the square root. Okay, so I'll write that here. If a is equal to b, then 2 to the a equals square root of 2. Okay, and so then what we find is that we would get x to the a times x to the a again, because x to the a and x to the b are the same thing, would be equal to x to the 1. Okay, and basically because all these bases are the same, I have this equation a 2a must be equal to a plus b must be equal to 1, and then a is equal to 1 half. Okay, and we can see that over here, so it must be 2 to the 1 half times 2 to the 1 half is equal to 2 to the 1. Okay, and the reason why is because 1 half plus 1 half would be equal to 1. Okay, so what that shows us then is that whenever we have a rational number exponent, okay, it means that we are now working with a root. And this would actually work for all of the roots. So for instance, if I give you, well, let's just draw a generalized formula first. If we did x to the 1 over a, that would give you the a root of x. Okay, and you can see that that's what we get over here. Okay, now really when we look at rational exponents, what we have is, let's say for instance we have x squared. Well, really this is already a rational exponent. It's just x to the power of 2 over 1, and what we're doing is finding the first root of x, which is just x. Okay, and then this squared means that the whole thing is all squared. And so what this means then is that if I had x to the a over b, it means that I'm finding the b root of x all to the a. And that's basically it. Now this can be a little bit complicated, especially when combined with some of the other rules, such as the negative value rules. And so for instance, if we have something like this, x to the negative a over b, and people can often get confused, but really it's just more of the same thing. Okay, so for instance, this is equal to the same thing as above, but then as you recall from, or probably recall from our previous lessons or one of my previous videos, this inverts or creates a reciprocal. So what we have is would be 1 over b root of x all to the a. Alright, and so often people will try and confuse you, or you'll see equations that are really kind of weird. It's just because they're combinations of things. But if you break it down into the individual components and just work with them one at a time, it's actually not so bad. Anyway, so you should be able to see that these rules apply here. Anyways, if you have any other questions, or if you have a comment or anything, drop me a line, leave a comment, or send me an email, and I'd be happy to try and help you out. Thanks for watching.